Hello, Ferdinand here again. Welcome to the third part of the Getting Started with the Cinema 4D C++ SDK under Windows guide. In this part we are going to debug, or in other words, run our build system and also explore some debugging techniques. So we are right off where we stopped last time. We have here our MSVC build system. So we didn't actually build Clang, but we built here the MSVC build system. And we have here this build output, so everything succeeded building. So if you remember, when we generated our build system, we set here the debug executable with which our project shall be debugged. And if we now click here this local Windows debugger button, this will happen. It basically tells us that it cannot find the debug application, which is a little bit surprising since we set it. And the reason for that is currently the all build project is the what Visual Studio calls the startup project. And if we look here into the debug configuration, we can see nothing is set there, and this is because this is a meta project which cannot be modified. So what we have to do is we have to change the startup project, which we can do by selecting one of our modules and then right-clicking so that the context menu opens, and then set as startup project. This will then be printed in bold. And when we look here into the debug configuration, we can see here that this Cinema 4D executable, which we defined here, is here linked as the debug application, and also the arguments of this command are set. So in this case, it will then set as an additional module path this path here, which is so this path here, it basically gives it the debug plugins path into which we build our module binaries as an additional module path, which means Cinema 4D will search for modules to load there in this path. And it also gives you this G-console argument, which makes it so that the console is attached. Yeah, this is pretty much all we have to do here. We can now press play or debug, and now the console starts and Cinema 4D is starting. And when we now look under extensions, we can see here the content of the SDK. So at this point you have successfully generated a project and built it and debugged it. So congratulations. I know this is a little bit of a journey, but as you can see, it's actually not that bad. You can of course now explore the content of the SDK. I won't do this here. One thing which I will point out is that when we go here into the preferences of our Cinema 4D instance and under plugins, we see there are here no plugin search paths. So although this thing sort of implies that it doesn't load modules, it actually does load modules / plugins. And this is because of the debug configuration which we set here. And the important point is that you should not manually set this path again in Visual Studio. First of all, not Visual Studio, in Cinema 4D. First of all, because you would then have to update every time you might regenerate or move your project. But more importantly is if you do both, then you will end up with a plugin collision, because it tries then to load the same plugin twice, and yeah, then you have a problem. So let's actually start this again, because I'm going to Now have a look at some details. Okay, so now we're going to go into our extensions and an example .main, and here we are going to look for the C++ SDK rounded tube example, which, as its name is an object generator or a procedural polygon object generator, which generates here this rounded tube thing. And now we're going to switch back to Visual Studio. And now we're going here into our, not example image, but example main. And there we are going to go into the source code and then into objects. And we are going to select here rounded tube, which is the implementation of the thing which we saw there. So this is an object data implementation. And we're going to go to the get, so this get virtual objects method. So we're going to there to its definition. And this method is being called when, so this is basically the major method of object data plugins which generate polygonal geometry. And this thing is called when Cinema 4D basically wants to build this geometry. And we're now going just to set here a breakpoint. You should set this below this dirty line, because this method is called very often. If you set this before, this will basically trigger all the time. And let's go back to Cinema 4D, and let's now, when I now want to, if I now change here any of these parameters, for example, here this main radius, then Cinema 4D will build this geometry again and our breakpoint will trigger. So as it did trigger there. And we can now, of course, step here through things, and we can also look here at the local values and use all the other debugging techniques which Visual Studio offers us. But what we are now again going to do is stop this debug session, and I'm going to paste in this code here, which you can find in the getting started manual, from which you probably got this video here. And I'm now going to explain what this code does. But before we do this, what we just did here reminded me of one thing, and that is, actually the indentation is not correct here. Something is here not right. Yeah, this looks much better. So Cinema 4D, or more precisely Maxon, uses in C++ tabs to indent code, and we use a tab width of 2 spaces. And I would highly recommend that you mimic this, because all our SDK is written in this fashion and all the frameworks are written in this fashion. And yeah, things will look weird when you do not follow this. So go to Tools option, and then just search here for tab, and then go to C++ tabs, and these 2 values here should be set to 2, and this should be set to keep tabs. And yeah, that's already it. So we now paste it in here, this code, and we do here basically we use here 2 important debugging techniques. And this is first of all the good old just printing out things, which are these 2 lines here. And the other thing is, of course, to programmatically induce a breakpoint or stop. So let's have a look at the printing things. So application output is basically the print function of the Cinema 4D API. And this will print to the application console of Cinema 4D, so the console which is built directly into Cinema 4D, but it will also print to the debug console of an IDE when a debugger is attached, so this output window here in case of Visual Studio. And it will also print to the so-called Maxon console, which can be attached with g_console equals true, which our setup does. But the thing is only visible when no IDE, or it's only important when no IDE is running itself. So we do not really need this here. And diagnostics output is sort of the debug print of Cinema 4D. So it also just prints stuff, but it doesn't put it into the application console of Cinema 4D. So it's not, you cannot see the output of that actually in Cinema 4D itself. You either need an attached IDE, so something like the output window here, or you need the Maxon console. So in the IDE and the Maxon console, this will be shown. There are also other print methods in our API. So these functions you see, they are actually just convenience functions around something called loggers, or yeah, we have loggers, and these loggers are meant for different purposes, and there are many loggers. If you want to know more about this subject, I would recommend reading the debugging manual. There's also a link to the specific logger manual, and it lists out the different output streams which are there and which you can use. As a side note, there are also older print functions in our API, something like geprint, for example. You should not use them. So the two main print functions you should be using is application output and diagnostics output. And you should be conservative with using application output, so you shouldn't spam the user with, I don't know, my plugin is booting and then loading this file and that file and doing this and that. So application output should be reserved to truly critical events. And diagnostics output, yeah, as its name implies, there you can be a bit more spammy in what you load and do. Yeah, and these two lines or statements, they are manually induced breakpoints or stops. And there are two flavors of this. So debug stop is a stop which is induced when you are debugging with a debug binary, so as we are doing now. And these stops are generally used in the fashion that you have some code, and this example is a little bit clinical. In practice, it would be often something like, oops. So when some error condition is met, then you raise a debug stop. So if you think go deeper into OI, there's something called if error macros, and there's something called an if error scope handler. And when basically an error is raised, then you might induce a debug stop. But this debug stop is, as already said, this will only be raised in a debug version. So if you would set this here to release and then compile, this debug stop would never be hit, even though true is always true. And then there are critical stops, which are, as their name implies, more critical. So they, for a debug stop, it's basically something like, okay, this event X happened here, which I didn't expect to happen, but the program is probably still able to continue to run properly. And the critical stop is the more critical version of this. So something happened and which you do not anticipate, and it's now very unlikely that this program can continue to run properly. And critical stop also is being raised when you are debugging against the release version. Otherwise, they are completely identical. So let's build our solution again. You can see it now. Rebuild here our rounded tube code example, and as you can see, it also updated here the example.main xdl64, which So if you remember, everything in these folders here, which are what Cinema calls a module, will be compiled into one binary, and because we updated code here in this example.main, it had to recompile the plugin binary, for example, .main, namely this file here. Okay, so this building went fine, so we can now start Cinema 4D again. And we can now add around the tube again. When I now going to insert the Cinema 4D, the first thing Cinema 4D will do is, of course, try to build its cache, or in other words, its geometry output, and therefore this debug stop will then halt. So it will run through this, it will print this, and then this debug stop will make us halt. So, and that's exactly what happened. We can, before we continue, we can also look at our debug output here. We see the application C SDK rounded tube, and this is here reflected by this line. So we are these print statements, they support string interpolation, and here this add symbol is then our basic placeholders for things to be interpolated, and we put here this op get name. Op is the object for which we built here the virtual objects, so the cache, the geometry output, and this thing is, as we will see in a second in Cinema 4D, this thing is called C SDK rounded tube. And here we also see the diagnostic output, which does exactly the same, only that we also print here the dirty state. So this thing basically computes if the cache for the thing has to be rebuilt. So this will always print true, because in order to reach this line, it has to pass this check. So this has to be always true here. Yeah, and we are now halting here at our debug stop, and we can also see this output here in the console. This should not happen, and we can now press, we could of course just step here now, but we can also just press continue, and now we hit this critical stop, and yeah, exactly the same. If I now print continue again, I think it will hit the debug stop once more. Okay, no, it didn't hit it once more. Sometimes the cache of things is built twice, and this could be happened hit once more. And yeah, now we are in Cinema again. And if you look here at the console, we can see here again this application output. So this thing, but we cannot see this because that's not being sent to the console of Cinema 4D. Yeah, and that concludes the meta techniques for debugging things. So everything pretty straightforward and pretty common. I hope this helps. Happy coding and happy rendering, and I hope I see you in the next video where we will finally start writing our own code. Bye bye.